You might be surprised to learn that, even in choppy waters, and when the ship is moving and rocking from side to side, helicopters can routinely and safely land on the flight deck of smaller ships. The bear trap makes the landing a little less difficult than you might anticipate, despite the fact that there is very little room for error. However, mistakes can still happen, which is why there are two conventional emergency protocols for helicopters that are unable to land on a ship's deck. There is a third alternative, however it is not what you might expect, and it is unconventional. Helicopter landings at sea are impacted by wind direction, ship motion, and sea conditions. Additionally, the airwake produced by a ship's superstructure might affect how well a helicopter performs. Ship helicopter operating limits, often known as Scholler S-hole, are the result of combining these and other criteria. A polar map indicating acceptable circumstances for conducting aircraft operations is known as the shoal. If you operate within these parameters, a helicopter ought to be able to land securely. However, it wasn't common practice back then to land a helicopter in choppy waters, because it was thought to be outside the chopper's operational parameters. The inability to land these helicopters in rough seas put a stop to Navy's efforts to employ ship-based helicopters for specific missions in the middle of the 1950s. That is, until the Royal Canadian Navy began testing a contraption that came to be known as a bear trap in the late 1950s and early 1960s. A rectangular device called a bear trap enables helicopters to take off and land from smaller ships like frigates and destroyers under a variety of circumstances. Bear trap technology made it possible for helicopters to be operated on smaller ships in choppy waters up to sea state 6, enabling them to handle 30 degrees of roll and 9 degrees of pitch, both during the day and at night. Following the Canadian success with the bear trap, the Royal Navy and the US Navy also adopted related technologies. This is how a bear trap from Canada operates. A cable that is lowered from the helicopter to the flight deck is attached to a probe. The rope is then connected to a winch below the flight deck by the flight deck crew, using their bare hands to pass through the bear trap center. An automatic hydraulic system controls the tension that is applied to the cable to keep it in place. By doing this, the ship and helicopter are in sync, the pilot reduces power, and the landing signal officer raises cable tension when they are confident that the motion of the ship and the helicopter is reasonably stable. The main probe of the helicopter is run into the center of the bear trap, which is then closed, while the pilot brings the helicopter to a stop. In addition to being able to capture and hold the helicopter in place, bear trap also has a rail system that it uses to transfer the aircraft into and out of the hangar. Although extremely useful, the original bear trap device had a drawback. Man overboard was a possibility in choppy waters, because handling the rope required the flight deck crew to be on the deck. Because of this, more sophisticated bear traps were created, such as Curtiss-Wright's ASIST advanced handling technology. The precise position of the helicopter in relation to the chosen landing spot is continuously tracked and monitored by ASIST using an optical positioning system. Without requiring any staff on deck, the helicopter is quickly aligned and traversed into the hangar after touching down, and is immediately secured using the bear trap. Bear trap is also known as RAST, the McTaggart-Trigon system, or Recovery Assist Secure and Traverse in some navies. Although there are many different types of recovery assistance, the most rely on a grappling tool or a probe that is fastened when the helicopter touches down and the bear trap is closed. A deck lock system that utilizes a steel grid in the center of the flight deck is an alternative to bear traps. In anticipation of the ideal time to drop, the pilot hovers above the grid. Once the helicopter has touched down, a locking harpoon is released, activating a hydraulic actuator system that drags the aircraft onto the deck. This technology has the advantage of not requiring any employees to approach the helicopter, especially in cases of strong seas. In the 1970s, the UK created a deck lock system that makes use of a harpoon mechanism, and it was tested on this moving platform. This system's ability to rotate the helicopter 360 degrees makes control easier and is a good feature. Bear trap and other similar systems have strategic value for smaller surface fighters that depend on helicopters. In 2014, a French business that sold their system to China drew the attention of the Japanese authorities. Japan created the first technology that could automatically land a helicopter on a moving ship a few years later, in 2017. For the purpose of approaching the ship, this system uses GPS navigation. Then, with an error range of just a few inches, the laser sensors on both ships are turned on to calculate the relative position of the helicopter to the moving ship. As a result, the helicopter can land automatically and safely. Despite all of this, there are situations in which helicopters cannot land on the flight deck, whether because of a problem with the helicopter or a problem with the flight deck. Sadly, there have been landing attempts that ended in fatalities. Emergency drills can improve survival chances, even though emergencies cannot always be avoided. Landing somewhere else is the first alternative to landing on the ship. Of course, this might not always be achievable, but since helicopters can be refueled from the ship while they are in the air, this can extend their range to the absolute limit. which in some circumstances can provide a different landing place. In-flight helicopter, when the helicopter drops a bag hooked to a cable onto the flight deck, refueling or HIFR begins. Once the cable has been hauled back onto the heli and connected to the fuel tank, the refueling team attaches the gasoline pipe to it. The hose is lowered after fueling is complete and the helicopter takes off. If you're wondering why there was a bag on the cable, it is used to lift up a fuel sample so that the flight crew may visually check it for fuel impurities. Additionally, the bag's weight stops the hoist rope from swaying as it is dropped onto the flight deck. The second choice is to land on water if landing aboard a ship is not a possibility. This is what occurred when a CH-46 Sea Knight's engine failed over the deck of the USNS Spica during a resupply mission. The cargo was instantly released, and the pilot cleared the deck. The pilot then managed to successfully land the helicopter on water by using autorotation. The crew managed to evacuate the rapidly sinking ship before the Sea Knight toppled to the right. Thanks to the emergency escape training that the crew would have previously received, everyone survived. Additionally, this was one of the first instances in which the helicopter crew used HEATS bottles in a genuine emergency. The third emergency option is extremely uncommon, but it asks what to do when there is only place for one helicopter to land on a ship, and many helicopters need to land there. In fact, this circumstance arose when the United States was removing its soldiers from Vietnam. Several South Vietnamese helicopters that were crammed with refugees trying to flee reached the ship as the evacuation fleet was leaving. The helicopters were allowed to land one at a time as part of a humanitarian endeavor. That is correct. In order to make place for the next helicopter to land, the crew skidded each helicopter off the ship once it had landed. In some instances, the pilot dropped off their passengers before making a crash landing in the ocean close to the ship in order to be rescued. But if you find this amazing, as it was, I should point out that a Cessna 01 dropped a message on the deck of the USS Midway, an American aircraft carrier, during one of these evacuations. "Can you relocate these helicopters to the other side? I can land on your runway and fly for another hour. We have time to move," it said. "Save me, please." Major Buang, his wife, and their 5 kids, a Vietnamese pilot and his family were there. The commanding officer of the Midway issued an order to evacuate the landing area, where a number of one Huey helicopters, estimated to be worth $10 million, were tossed overboard. The first fixed-wing pilot of the South Vietnam Air Force to ever land aboard a ship, Major Buang, accomplished the feat safely. Later on that afternoon, USS Midway also managed to land another Cessna 01.